So yesterday, we were able to see the 4 quadrilaterals and their attributes. Parallelogram, we said it has 5 attributes. Rectangles, 7, rhombus, 7, and then square, 9. And by now, we should all know the attributes of these 4 wonderful quadrilaterals. And in addition to that, yesterday we just diverted a bit by studying trapezoid, where we said a trapezoid is a quadrilateral, meaning a 4-sided figure with only one pair of parallel sides. And the parallel sides are called bases, and the 2 other sides, the non-parallel sides, are called legs. And since a trapezoid is also a quadrilateral 4-sided figure, the sum of interior angle there is 360. And we also said the consecutive parallel interior angles will always be supplementary in a trapezoid, okay? So we're gonna quickly review this thing here today. In terms of the diagonals of parallelogram, what did we say? We said one specific thing about the diagonal of a parallelogram. We said 2 specific things about the diagonals of a rectangle, 2 specific things about the diagonals of a rhombus, and 3 specific things about the diagonals of a square. Can someone recall what we talked about the diagonals of a parallelogram? In a parallelogram, do the diagonals intersect?
They bisect each other.
Okay, since they bisect each other, we're gonna say bisect. What about rectangle? Do they bisect?
Yeah.
Okay. What about rhombus? Do they bisect?
Yeah.
Okay. In a square too, do they bisect?
Yeah.
Okay. So it means in these 4 quadrilaterals, the diagonals will always bisect, okay, each other. They will definitely intersect. And in addition to that, in a rectangle, what did we say about the diagonals? We said something yesterday about the diagonals of a rectangle. Okay, thank you, Savannah. We said that the diagonals are congruent in the case of a rectangle. What about rhombus? What did we say about the diagonals of a rhombus? The diagonals of a rhombus always form a right angle. So when 2 lines form a right angle, what's the other name to call them? It starts with P.
Perpendicular.
Okay. And in the case of a square carries it all. Square carries the, square carries the additional attributes of the diagonals of rectangles and rhombus. So what we're gonna put here, in a square, the diagonals are congruent and what? Perpendicular. So these are things that happens to the diagonals of these 4 quadrilateral. In a parallelogram, the diagonal bisects each other. In a rectangle, the diagonal bisect each other and they are congruent. In a rhombus, the diagonals bisect each other and they are perpendicular. And in a square, the diagonals bisect each other, they are congruent and they are perpendicular as well. So now we have a quadrilateral ABCD with each of these points A, B, C, D with their coordinates. we're gonna then try to locate these various points on this coordinate plane, and then try to see what else they're asking us for. And here they say, what type of quadrilateral is ABCD? So let's locate A. A has coordinate x 6, y 6. If s is 6 here, y is 6 here, they're gonna meet somewhere here to form A. For B, B has x value to be 4, and then y value to be -6. So -6 and 4 meet somewhere here. So this is B. And going forward, C is -8 and -4. -8 here on X, -4 here on Y. So if you trace this down here, the point of contact here is this point here. So I'm gonna delete the 2 lines. Okay. And then lastly, D has X value -6 and the Y value 8. So it's gonna be something here, because this big red dot has X value 6 and Y value 8, okay? Then I'm gonna erase anything that will confuse me. I'm gonna join, oh, I even forgot to write C here and D. So I'm gonna join these points. Can I pick shape? Okay, let me pick shape. I joined A to B, B to C, and C to D. And I got something like this. So this is A, B, C, D. So if you want to really determine if ABCD is a parallelogram, because they said what kind of quadrilateral is this? So, and we know we have 4 major types of quadrilateral that we know very well. These 4 guys we've enumerated above here: parallelogram, rectangles, rhombus, and square. So let's see that. Let's first of all start with parallelogram, because parallelogram is a big family. Once it's a parallelogram, so it means it can also be either rhombus or rectangle. And once it's either, rhombus and rectangle at the same time, then it's definitely a square, okay? So let's verify the condition for parallelogram by checking the diagonals, okay? So here, that's why the statement said we can determine if ABCD is a parallelogram by checking to see if the diagonal do what? The diagonals bisect, okay? So to verify if a 4-sided figure is a parallelogram, make sure you just verify if the diagonals bisect, okay? So by doing that, what do we do here? So we're just gonna compare the midpoints. We're gonna look for the midpoint of AC. So we're gonna trace the diagonal of, let me check drawing, okay. We're gonna look for the diagonal of AC. And then this BD. So as you can see here, the diagonal here cuts at X value being -1 and Y value being 1. So the diagonal, if it is E has coordinates -1 as X and 1 as Y. But let's just, mathematics is about proving things. So we're gonna just go with the calculation. And we know the midpoint formula since 6, I think unit 6. To get the midpoint of a line segment, what do? you add the x, you take the average of the x values and the average of the y values. By average, I mean x1 plus x2 over 2, x1, y1 plus y2 over 2, okay? So you're gonna do the same thing here. We're gonna find the midpoints. This is gonna mean midpoint, okay? Midpoint of AC. We have A and C, A and C. The x value of A is what? 6. The x value of C is -8 over 2. And 6 minus 8 is -2 over 2. -2 over 2 is what? -1. Okay, let me manage the space very well. This space is quite little. I'm going to do the x value of this to be 6. The x value of C is -8 over 2. Then I'm going to go for the y value of A, which is 6. Y value of C, -4 over 2. And 6 minus 8 is -2. -2 divided by 2 is what? -1. For y value, I'm going to do 6 minus 4 is what? 6 minus 4 is 2. 2 divided by 2 is 1. So I was able to find the midpoint of AC to be -1, 1. I'm going to see if it's going to give me the same thing on the geometric representation of what I just did. I'm also going to find the midpoint of BD. You see this BD, this diagonal BD. So I'm going to write M middle point, MD for mid, PT for point of BD. B has X value 4, Y value, D has Y value 6, -6. Then I'm going to take the average. On the other side, B again has Y value -6, and then Y value, D has Y value 8. When I do 4 minus 6, that gives me -2. -2 divided by 2, -1. -6 plus 8 is the same as 8 minus 6, okay? 8 minus 6 is 2. 2 divided by 2 is 1. So as you can see, this means ABCD is a parallelogram. Since the diagonals bisect, then ABCD is a parallelogram. Okay? Because we said one of the attributes of parallelogram is that the diagonals bisect. Since we're able to see that the midpoint of AC is -1, 1, and the midpoint of BD is also -1, 1. So it means they have the same midpoint. And if they have the same midpoint, that means what? They bisect. If Savannah goes to Snyder High School, and Jovara also goes to Snyder High School, how will I know that they bisect? Because now I can see both of them in my classroom. So if I can see both of them in my classroom, then it means they really go to Snyder High School. I might see anybody outside there. I might see someone walking around coming to the building. I might not, I won't be bold to say that that person is really a Snyder High School student until I see that person, that individual in a classroom or in my classroom. Then I can vouch for that person that, okay, he or she is really a student of this environment. So it's the same thing. Since the midpoint, there's a common point to those two diagonals, then it means that particular parallelogram is, that particular quadrilateral is a parallelogram, because the midpoint, is a point of intersection of those two diagonals. And since this quadrilateral is a parallelogram, what next can we verify? We can either verify if this thing is a rhombus or a rectangle. And to verify if it's a rectangle, what do we need to check? The attribute of the diagonals of a rectangle, we said they bisect each other. But since we're able to say they bisect each other under parallelogram, so we don't need to verify that again. The next thing to verify is just to see if the diagonals are congruent, okay? The second aspect here. Let's see, because we're able to verify this, which is particular to parallelogram. And since this one is already verified and we want to see if it's a rectangle, what do? This one has already been seen above. Then let's check this guy, if the diagonals are congruent. Then what do? To see if diagonals are congruent, we only need to take the distance of the two diagonals AC and BD to check their distances if they are the same, okay? So we're gonna verify the distances. And you know the distance formula too. So mathematics, everything is interrelated. Whatever you've learned here since the beginning of this class in August is still coming here. Whatever you've learned in your middle school will still come here. And whatever you are learning today, when you go to college or university later in life, you're gonna meet the same thing. Your first 2 years in college, these are the things you're gonna be doing, distance formula, but in advanced way. But there's nothing to be scared of because the same thing. Just manage to know these formulas very well. And when you get there, you apply them, you know. The professor will think, oh, he or she really went to a good school, or he or she was really taught, and he or she really grabbed what was going on. So here, let's look for the distance. Since AB is a diagonal, I'm gonna put those diagonal in another color entirely. Okay, let me check the colors of the diagonal. So we're gonna look for distance AC. And we know distance formula to be what? Square root of the sum of the difference of this, of the square of each of the X and Y components. What do I mean by that? Distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. So in another way, to say this, the whole of this square root in English, you would just say distance formula is the square root, because of this b square root, of the sum means this, of the difference means this minus, of the square of the x and y values. So mathematics is a language. All these mathematical jargon we are writing, you can interpret them in English without even writing them down. Distance is the square root of the sum of the difference of the square of the x and y values. So if we do that, in our first component, we are dealing with A and C. The x value of A, the x value of C is -8. So we're going to take -8. The x value of A is 6. So minus, there's already a minus here. So -6. Let me put here x1, x2, y2, x1, y1, x2, y2, x1, y1. Plus, we're gonna take the difference of the y component. Y2 at C is -4. And then at A, y is 6, so -6, because of this minus in the middle here each time, okay? So if you do that, take the square of this guy. So if you do that, -6 minus -8 minus 6 is -14, okay? minus, so the other side, you're gonna have minus 14 squared plus minus 4 minus 6 is also minus 10 squared. So if you put this in your calculator, you're gonna give you 17.2. We're able to find AC to be 17.2. Let's find BD. So you're gonna take also distance BD, which gonna be the square root of the sum of the difference of the square of the x values minus 6 minus, for the other one, minus 6 minus 4. Here, this is minus 6. Here, this is 4. So minus 4, this minus inside here. For the y values, the y of there is 8. And the y of here is minus 6. And minus times minus is what? Plus. So as you can see, we are having the same numbers. Minus 6 minus 4 is minus 10 square as this guy here. Then 8 plus 6 is what? 14, which looks like this guy. Here it's negative 14, but when you take the square of a negative number, it becomes positive. Okay, minus times minus is plus. So negative 14 square and 14 square are the same numbers, okay? So as you can see, the two numbers under the square root here are the same. Minus 14 square and 14 square are the same. Minus 10 square and minus 10 square are the same. So that means we're going to have the same outcome, that will be 12.817.2. And since the diagonals are the same, then we can say those diagonals are congruent. And when the diagonals are congruent, then this means ABCD is a rectangle. Since the shape, the quadrilateral is a parallelogram, because we're able to see that the diagonals bisect, they meet at the same point E, minus 1, minus 1, 1. And we're able to show that this same parallel quadrilateral, being a parallelogram, is also a rectangle because the diagonals have the same distance, AC being equals to BD. For us to show if it's a rhombus, for the case of rhombus, this is what we needed to show. Since we have already said that they bisect, let's see if they are perpendicular. In our first semester, how did we show that distances are perpendicular? Two distances are perpendicular. By checking what? The slope. So we're going to check the slope. If two lines are parallel, they're going to have the same slopes. But if two lines are perpendicular, the product of their slope will give us what? Minus 1. Or one slope is the negative reciprocal of the second. Or when you multiply the two slopes, it has to give you minus 1. So let's see. So in case of rhombus, they need to be perpendicular. So the comparison is going to be around the slopes. So this is a good recall. We said, well, in our first semester, for two lines to be parallel, they must have the same slope. For two lines to be perpendicular, they must have negative, the product of the slopes have to be negative 1, or one has to be the negative reciprocal of the other. And then if we forgot how to get slope, slope used to be M equals to the difference in Y guys over the difference in X guys. Okay. The difference of the X component over the difference of the Y component. So delta Y over delta X. So slope means opposite reciprocal. Then let's find slope BD. We want to find the slope of this diagonal and find the slope of the other diagonal. We want to check if really we're going to have a box here. So the slope, since BD goes downward, so it means the slope going to be what? Negative. The slope, once a line has a negative slope, when a line has a negative slope, it means that line will be decreasing, be going downward. A line with positive slope will always go upward, okay, from left to right. So BD, as you can see, it's going downward, then it's gonna have a negative slope. But anyway, let's do the calculation to ascertain our claim. Our X component, our Y component here to B and D. Y component at B here is -6, and then the Y component at D is 8. So it will -6 -6 -8 over the X component. X component to B and D here, 4 minus 6. That will be positive. Oh, let me see. When you're calculating slope, you have to go from the last letter to the first letter, okay? So the X component at D is -6 minus 8. So that gives you 8 plus 6. 8 minus 6, which is +6. The Y component is -6 minus 4. As you can see, the X component here, -6 minus 6 minus 4. This minus this, and the other guy, 8 minus 6, which is 8 plus 6. Then if you do 8 plus 6, 14. 6 minus 4, minus 6 minus 4 is -10. So 14 over -10 gives you, we have 14 now over -10. We can keep it in fractional form. So if you divide both numbers by 2, 17 divided by 2, 14 divided by 2 is 7. 10 divided by 2 is 5. So let's keep this minus number in front. So this is the first number we got. Let's also find the slope of AC rather, the other diagonal. That will be -4 minus 6. As you can see here, AC -4 minus 6, because there's a minus in between because of the difference. And then the Y component, the X component going to be -8 minus 6. Then -6 minus 4 is -10. -8 minus 4 is -14. And then if you do your calculation here very well, so you're going to have 5 over 7. And as you can see, if you multiply the two numbers, -7 over 5 times 5 over 7, that will be -35 over 35, which is what? -1. So it means the two slopes are negative reciprocal for each other. So here, this means ABCD is a rhombus. And a shape that is both rectangle and rhombus is what? Is definitely a square. So you don't need to verify all these guys again. Because the case of a square, at the beginning we said the diagonal is bisect. Where through rectangle, we're able to say that the diagonals are congruent, and through rhombus, we're able to say that the diagonals are perpendicular. So the square is automatically seen here. I think, should we stop here? Because this is long, man. And this one too is the same thing. You're gonna do the same thing again. Make sure you plot all these A, B, C, D on this shape here on this coordinate plane. To show that it's a parallelogram, you need to first of all say the diagonals bisect. And then to show that the diagonals bisect, you need to find the midpoints if the midpoints are on the same space. If the midpoints are equal. So finding the midpoint, if you find the midpoint of AC, A to C, A, C, 4 minus 5 over 2, and minus 4 plus 7 over 2. Then the average here is minus 0.5, comma 1.5. So if you do your calculation very well, here too you find the midpoint of BD. BD, this is gonna be 7 plus minus 2, so 7 minus 2 over 2, that's 5 over 2. And then the other side, minus 2 plus 3 over 2, that's 1 over 2. So here the outcome here gonna be 2.5, comma 0.5. Since, as you can see, these two numbers are not the same, this number is quite different from this, then the midpoint here is not, this means ABCD is not a parallelogram. Because if we do the drawing very well, A has X minus 5 and Y 7, say A something somewhere here. B 7, 3 somewhere here. C 4 minus 4 somewhere here. D minus 2 somewhere here. So if you trace this, trace this, trace this. So if you can see very well, you see that this thing really looks like a trapezoid, so it doesn't even look like a parallelogram. But if you check the midpoint and the C, you see that the midpoint are not the same, then there's nothing to look up to again. And since the midpoint are not, the midpoint are not the same, and it's not a parallelogram, therefore it cannot be a rhombus, it cannot be a rectangle, and it cannot be a square. Which shape could it be? And we can then verify if it could be a trapezoid by doing what? And we know that a trapezoid, we're just going to recall all these attributes of trapezoid. A trapezoid has one set of parallel side. Then we're going to see if we're going to check the slope of these two sides. This is A, B, C, D. Let's look at the slope of AB and the slope of DC. If they are the same, then we can say the two lines are parallel. And if the two lines are parallel, then we can definitely say that this is a trapezoid, okay? Because a trapezoid has only one side, one set of parallel sides. And as you can see, AB goes downward, DC goes downward, so the slope is going to be negative. Then let's see if they are the same. Let's see, let's quickly look at the slopes. The slope of AB we have 3 minus 7, A, B, C. 3 minus 7, 3 here, y, x, 7 minus 5, minus 5, which is 7 plus 5. And this gives us minus 14 over 12. Then minus 4 over 12. 3 minus 7 is minus 4. 7 plus 5 is 12. So if you divide up and down by 4, 4 divided by 4 is 1. 12 divided by 4 is 3. So we have minus 1 over 3. Let's also find the slope of DC. The y component of D is minus 2. The y component of C is plus 4. And then the x components are minus 2, minus 4. Minus 2 plus 4 is 2. Minus 2 minus 4 is minus 6. If you divide 2 by 2, you have 1. You divide minus 3 by minus 6 by 2, you have minus 3. As you can see, this number is the same as this number. So here they have the same slopes. And since these two lines, AB, and DC have the same slopes, then it means both of them are parallel. Then it means ABCD is a trapezoid. Oh, it was a long something anyway. But anyways, whatever we needed to learn today is to see on a coordinate plane if shapes a quadrilateral is either a parallelogram. You need to check the midpoint, the midpoint of the diagonals, okay? If they have the same midpoint, that means that quadrilateral is a parallelogram. To verify if that quadrilateral is a rectangle, in addition of checking the midpoint to see that they bisect, you also need to check the two diagonals, the distances of the two diagonals. If they are the same, then it means the diagonals are congruent, then it's a rectangle. To verify if it's a rhombus, just try to see the slopes of the two diagonals. If the product of the slopes are, if the product of the slope is -1, then it means one slope is a negative reciprocal of the other, then they are perpendicular. To see if a specific quadrilateral is a square, you have to first of all look at if the diagonals bisect by looking at the midpoint of the two diagonals if they are the same. Then verify if the diagonals are congruent by checking the distances of the two diagonals if they are the same by using distance formula. And lastly, you need also to check if the diagonals are perpendicular by looking at their slopes. If the product of the slopes is -1, then you have the same slope. So 3 formulas not to forget again: distance formula, midpoint formula, slope formula. And for the case of trapezoid, just to look at, try to see if the two sides that looks parallel are really parallel by looking at their slopes. If they are the same slope, that means they are parallel, okay? And in a trapezoid, we only have one set of parallel lines. So the homework is also on our page that you can make use of. Let me see what is there. So what do we use to determine that a quadrilateral is a parallelogram? Just use the midpoint formula, okay? Okay, ABCD is a parallelogram, yes, because the int here says AC and BD are diagonals. And then the next one, to determine if it's a rectangle, just do what? The distance formula, okay? Distance formula to just look at the diagonals, okay? Here you need to also draw, you need to draw, virtually you need to draw this shape to see really what it's talking about. If this is your coordinate plane rather, -3, -4, A gonna be here. B 5, -3, B gonna be somewhere here. C 1, 4, I'm just trying to draw out of the scale. 7 -7, 3, B gonna be somewhere here. So if you join them, what did he say? Is a rectangle because the name is ABCD. AC is a diagonal, and then BD is a diagonal. Yes. So this is yes. And to find if it's a rhombus, what do you need to do? Slope. Look at the slope. If the two slopes are, the product of the slopes is -1, then it's a rhombus. Here too is the same thing because the same shape, then the diagonals AC and BD. This means it's a square, yes. So here, this is what part of what we did yesterday. To find C, you're gonna do 180 minus 70. To find A, 180 minus 65. And if you're able to find A, just do 180 minus the value of A to find B. These are things we've done so far. Parallelogram must be either rectangle or rhombus, yes. Every rhombus is never a rectangle because in a rhombus, diagonals are perpendicular, but in a rectangle, the diagonals are not perpendicular, they are just congruent. So you need to be very careful about the use of English here. All rectangles are parallelogram because rectangle is under parallelogram, okay? Every square, yes, square is under rhombus and rectangles, and both of them are under parallelogram. So square is also under parallelogram, true. Here, the number of rotation gonna be here to get what you're looking for. How do I get this? Okay, we have 1, 2, 3, 4, 5, 6. So you're gonna do 360 divided by 4, that's 90. So anytime you add 90, whatever you get here, add 90 to it, and then you continue. Those will be your choices. 90 plus 90, whatever you get is your choice. Add 90 to it again, and you go on like that till you reach 360. Yes, this one has line symmetry, yes. Here, this is a parallelogram, yes, because opposite sides are parallel. And then it's not a rectangle because none of each interior angle is 90. It's neither a square, and it's not hexagon because none of the side, we don't have 6 sides here. It's not a square because none of this interior angle is 90. And rhombus, yes, because all the sides are 13.6. This is part of what we did yesterday. This one too is part of the test. Just do 11 times 12.7 times the number of sides divided by 2. The last one is optional. Make sure you do something, and if you don't do, just leave it like that. So class, it has been a long day. I really appreciate your patience, even though it was a bit of rush, but tomorrow we're gonna review most of these things, okay? Till then, do have a wonderful day. Make sure you submit your homework. Thailandis, are you back? Angela, are you back?
Yeah.
Okay, Jade, is she there? Damon, is he there? Jovara, okay, Jovara is here. Thank you so much. Have a great day. Bye.